Hello. In today's lecture, I will be discussing about Gauss's law. First of all, I will discuss about what is electric field and then discuss about electric field lines. That will be the basis to discuss Gauss's law. Then I will describe about electric flux and how to calculate electric flux. That is very important because without knowing how to calculate electric flux and what actually it is, we cannot discuss Gauss's law. And finally, I will state the Gauss law and discuss about it, which is actually the relationship between electric flux and its charge enclosed by the surface. Let's dive in. So first of all, what is the electric field? To discuss about electric field, first of all, we should know about the basic electronic charges. So there are two kinds of electronic charges, positive that we call protons and negative that we call electrons. So these are two kinds of basic electronic charges. So wherever you have electric charge, whether it is positive or negative, there will be electric field associated with it, around it, that we call electric field. It is not visible, but there is some kind of effect, some kind of force around it that we call electric field. So to represent that electric field, we have to draw some kind of imaginary lines that we call electric field lines. Look at here. This is a two equal and opposite charges that we call a dipole. And the interaction between these two charges can be represented in the form of electric field lines. See in this figure, the beautiful lines. The electric field lines are coming out from the positive charges. Look at here, this arrowhead is indicating the direction from which electric field lines are emerging and going into. These field lines are going into the negative and coming out from the positive, right? They are never intersecting with each other. And look at here, electric field vector, which is represented by E, is always perpendicular, tangent to the electric field lines. Okay, these are few properties related to electric field lines. So this is about the electric field. Now let's define electric flux. If you have an electric charge, there will be electric field lines. It is some kind of flow, like a water flow, right? Because electric field lines are coming out from the positive charge and going into the negative. There is some kind of flow, right? So we can call it electric flow. Actually, the electric flux is the number of electric lines or pores. We can say it electric field lines passing through certain area, right? Intersecting certain area. Look at this figure. We have certain area A represented by this area, and electric field lines represented by E are pointing towards positive x-axis, and they are intersecting this area, right? So this is flux. How many number of lines, electric field lines are intersecting this area? That gives you electric flux. Okay. Now we need to know the technique how to calculate electric flux. That is the most important. To calculate electric flux, let's consider this relation. So, which is electric field lines. These are the electric field lines. And this area is perpendicular to the electric field lines. And here is the area vector, which is perpendicular to this surface, right? In this case, the angle between this electric field lines and area vector is 0, pi equal to 0. Okay, so the total electric flux, that is actually the total electric field lines passing through this surface, is given by the dot product of these two vectors E and A, E dot A, which is equal to EA. Cos 0 means 1. That's why it will be EA. It will be EA. Okay. So this is the maximum electric flux that can pass through this area. So let's see this kind of case. If this surface is tilted, what will happen? In this case, number of electric field lines passing through this surface is less than the previous case, right? Because it is tilted. So in this case, you can calculate the electric flux, and the electric flux pi E depends on this angle. If this angle is small, the electric flux will be different. If this angle is big, electric flux is different passing through this surface. Okay, so this is the second scenario. In third scenario, this could be the case. In this case, this surface A is as on to the electric field, right? So in this case, no electric field lines are passing through this surface, and the angle between this area vector A and the electric field lines is 90 degrees. So if you insert a value of pi in this equation, total electric flux will be 0, which is the minimum electric flux passing through certain surface, right? When the surface is as on position, the electric flux will be minimum, which is 0. When the surface is face on position, as like the beginning one, first one, then the electric flux passing through that surface is maximum. Remember that. So what if electric field is not uniform? You cannot use this equation right here, this equation, if electric flux is not constant. Electric flux is changing over the surface. So to calculate electric flux in that case, we have to split this surface into small surface elements, area elements like dA, and then calculate electric flux for that particular small electric flux, right? For example, right here, this is a small surface area dA, and a small flux passing through this surface is equal to E dot P, right? Similarly, you can calculate electric flux for these small areas and add them up. That is the calculus, right? Integration. Integrating the total flux through this surface, will be getting the total flux passing through this surface in which electric field is not uniform, right? So integration of d phi E, which is the total flux passing through this surface, will be equal to integration of E dot dA. Okay, so this is the total flux. So the electric flux can be written or calculated by this equation. This is the same equation presented in different product. Look at here, the electric flux is represented by pi E and equal to integration of E cosine phi, which is the angle between E and this surface area vector dA, and then d, right? Or you can express in terms of E perpendicular dA, which is E perpendicular is E cos phi, and also in terms of vector elements or vector product of E dot dA. So this is very nice equation to calculate electric flux. So SI unit of electric flux is Newton meter square per coulomb. Here is the question for you. If the angle between the electric field lines and area vector is 90 degree, the electric flux will be maximum, minimum, neither maximum nor minimum, none of the above. Okay, you can answer this question based on we discussed three kind of cases, right? The maximum case, minimum case, and between. So look at here. In this case, angle between electric field lines and area vector is 90 degree. Okay, so while calculating electric flux, we have formula to calculate the electric flux that associates cosine. So cosine of 90 will give you the minimum, right? Look at this condition. When cosine angle is 90 degree, right? In this case, the angle is 90 degree, angle between this area vector. Always remember this area, the surface area and area vector is are two different things. It's not same thing because this is perpendicular. This area vector is perpendicular to this surface. However, this surface area is parallel to the electric field lines. Remember this. Okay, so this gives you total electric flux equal to 0. That means it is minimum case. Okay, just for follow-up. So now we arrived here, we are able to state and discuss Gauss's law because we have tool how to present Gauss law and discuss about it. Okay, what is Gauss law all about? It is quite simple. If you have a charge, certain charge here, charge Q, let's say, and just draw a surface that we call Gaussian surface. And our goal is to find electric field in this surface and find a relationship between electric field on this surface, electric field on this Gaussian surface, and the charge enclosed. That is Gauss's law. Quite simple. Okay, let's define Gauss law. Gauss law states that the total electric flux through a closed surface that we call Gaussian surface is equal to the net electric charge, total electric charge inside that Gaussian surface divided by electric constant. That is Gauss law. So pi E, which is the electric flux passing through this Gaussian surface right here, will be equal to, this is actually the total flux, right? E dot dA in integration form is equal to total charge enclosed by this surface. Look at here. In this case, the surface is like a sphere. It should not be, it could be any shape, just enclosing shape, right? And then total charge enclosed by this surface is Q enclosed divided by epsilon, right? Which is basic electric constant. Okay, so this is Gauss law. In summary, what do we learn today? We learned about electric flux and how to calculate it. So how to calculate it? We should use this formula. The electric flux denoted by pi E will be equal to integration of E cos phi dA. This is a small surface element, right? This is magnitude of electric field E, and pi is angle between E and A, area vector. Okay, so it can also be presented in other forms like this. And the Gauss law is a relationship between electric flux through a closed surface of area A, which is actually the surface integral of E, and this is equal to the total charge enclosed by that Gaussian surface divided by electric constant. So this is all about Gauss's law. This is one of the most important equation, one of the Maxwell's equation of electromagnetism, which is very important to know.